So now we need to talk about the complement rule. So the complement of an event E that's in a sample space S is all the outcomes that are in the sample space that are not in event E. And the complement in our book is denoted by the same letter as the event with a little c subscript, which stands for complement. Sometimes you might see a problem where you see the same letter as the event with a bar over it. Okay, so let's explore for a little bit. What if our sample space S is the letters A, B, C, D, E, and event E is the vowels? So there are two vowels in S, and they are A and E. So let's draw the sample space. Here's our sample space. And here's our event E. So E has the letter A in it, and it has the letter E in it, which means that S, outside of E, contains the letters B, D, and E. So let me go back to some shading. So this is what E is, right inside there. And everything that's outside of E, but still inside the sample space. So all the stuff I'm shading blue here, or attempting to anyway. All of that blue stuff is our complement E, C. So S is the whole thing, E is what E is, and EC is everything that's in S but not in E. So we've sort of already done this. Listing the elements in event E gives us A and E, the two vowels. So what elements are in the complement? Well, we already did that too. It's B, D, and I don't know why I did that. It's not B, D, and E. It's B, C, and D. E is in E. So sorry about that. Should be B, C, and D. I'm just going to tack C on the end. It doesn't matter whether it's in order or not. And let me go back and put this highlighter back in. While we're on the subject of me making mistakes, remember, mistakes are not always bad. Sometimes the best learning occurs when you make an error. And the other thing is, it's not the end of the world. You just go back and fix it. Okay, so what is the probability of E? Well, remember, it's the number of things in E divided by the total number of things in the sample space. So that's 2/5, which is 0.4. What's the probability of the complement? Well, the probability of the complement of E, there are 3 things in the complement out of 5 total things. So that equals 0.6. So what's the probability of E plus E complement? So the probability of E plus the probability of E complement is 0.4 plus 0.6, which is 1. Now, what's the probability of all of S? Well, there are 5 total things in S. So the probability of, since there are 5 of them, 5 goes in the numerator. And of course, we always put the total number of things in the denominator. 5 divided by 5 is 1. So here's why it makes sense that the probability of the event and the probability of its complement is 1. Because E incorporates some things out of S, right? And by definition, the complement is everything else. So between the two of them, so they're the same for why the probabilities are the same. But here's what happens. E so this right side up thing that looks like a capital U, that is what we call a union symbol. And all it means is that we are combining E with, in this case, the complement. Okay, hopefully that makes sense. Will the results always work out that way? Yes. Yes, they will. And that's good because, scrolling down some more here, we can write the complement rule in 3 ways. One of them we already discovered on our own. The probability of an event plus the probability of its complement is 1. Now, by doing some algebraic rearranging, we can say that the probability of the complement equals 1 minus the probability of the event. Or, if we rearrange it a different way, the probability of an event equals 1 minus the probability of its complement. Now, out of these 3 options, the one we use most of the time, well, probably we use these 2 equivalently. So the top one we rarely use. Okay, so what's an example of this? So they've given us the probability of E, and they want the probability of E complement. So the probability of E complement, using what we know, is 1 minus the probability of the event, which is 1 minus, they told us the probability of the event was 0.328. And so all we have to do is crunch the numbers, and we get the probability of the complement then is 0.672. Okay, so that concludes the video lectures. I am going to do the activity that will be posted with these notes in another video and attach it into the video assignment right after this one, but you don't have to watch that one, but you should, because I think doing the activity will help you understand.